All right, we're going to be looking at some velocity versus time graphs. And with these graphs, we're going to review constant motion, but now we're going to be adding in a changing motion or a changing velocity. So remember, a changing velocity means acceleration, and you can have acceleration with either an increase in velocity or a decrease in velocity. So in the past, we have looked at what a zero speed or an object at rest looks like on a velocity versus time graph. We've also looked at constant speed, either in the positive or the negative direction. So remember, it's kind of like cruise control. The object's either moving 2 meters per second to the right for the entire 10 seconds, or maybe it's moving negative 3 meters per second, which would be to the left for the entire 10 seconds. So some sort of constant motion. Well, now we're going to start looking at positive and negative acceleration. So when we talk about positive acceleration, that means that you're going to be seeing a positive slope. So that positive slope just indicates that the object is moving in the positive direction. So again, to the right or north. On the other hand, when we're looking at negative acceleration, this is going to have some sort of negative slope. So that means that the object is moving in the negative direction. So remember, positive slope would be looking like this, and a negative slope would look similar to this. All right, so in the past, we've already looked at some of the constant motion on these velocity versus time graphs, and so far they had all had horizontal lines. These horizontal lines represent that constant velocity that we looked at. So if the horizontal line is at 0, that would mean the object is stationary. If the horizontal line is above 0, that would mean it's a constant positive velocity. And if the horizontal line is below 0, that would mean it's a constant negative velocity. So object stationary, it would look like this orange line on the graph. If the object is moving at a constant positive velocity, so here 4 meters per second to the right is indicated with the blue line. And then if it's a constant negative velocity, it would look like this purple line, so 5 meters per second to the left or south. So it's at the negative 5 here on the graph. All right. These velocity versus time graphs, if you have the data and you have a line drawn, you can find the slope of the graph. And the slope of a velocity versus time graph is going to be equal to the object's acceleration, and I will show you. So remember that to find acceleration is equal to the change in the velocity. So here we have our change in velocity divided by our change in time, and here's our change in time. So our change in velocity is the change in the y values on this graph because we have velocity on our y-axis here. And then our change in time would be the change in the x values. So our change in x values are going to be represented by time because time is measured on our x-axis. So just to show you what our slope would be for this line, let's pick 2 points. And again, you could do slope as the change in y values over the change in x values, or you can always do rise over run. Both will give you the same answer. So the slope would be, our first point would be here, our second point would be here. So our y2 point would be 30 meters per second, as you can see here. And our first y value would be 10 meters per second. So you'd have 30 minus 10, check. Then you would have our x2 values, so 30 minus 0. So we have that here. And once you simplify, you'll get 20 divided by 30, or you'll get 0.67. Which is the same thing you would get if you did rise over run. So if you did rise over run, you would go up 20 meters per second and then over 30 meters per second, which would also give you 0.67 or 2/3 meters per second squared. All right. So with these graphs, first we're going to look at positive acceleration. So remember, positive acceleration means that the line on the graph has a positive slope. So the object is undergoing an acceleration in the positive direction. So the line could look like this. As you can see on this line, the object starts moving. Maybe it's 4 meters per second. So the object starts moving not at 0, but at 4 meters per second, and then it increases 8 meters per second, 10 meters per second, 15 meters per second. It keeps increasing. So the speed is increasing and it's moving more in the positive direction, so further to the right. So if the velocity is positive, which it is in this case because we're looking at the positive portion of the graph, and there's a positive slope, meaning a positive acceleration. So because you have both velocity and acceleration as being positive, the object is speeding up, and you can see that by analyzing numbers. We went from 8 meters per second, 10, 12, 14, 16. We are increasing in speed. On the other hand, if you have another positive slope, but this time it's in the negative portion of the graph, so here our velocity is negative because we're in the negative portion of our velocity versus time graph. So if we apply numbers, maybe we start at 8 meters per second. However, it's in the negative portion of the graph. So we're in the leftward position of the origin. So we go from 8 meters per second left to 6 meters per second, 4, 2, and then eventually we go to 0. The object is slowing down. So although you have a positive acceleration, that just means that the object's moving towards the positive direction. It's trying to get over the origin and continue moving towards the positive direction, which would be right or north. So the velocity here was negative. We were in the negative position of the graph, but the acceleration was positive because we have this positive slope. So our signs are different. That means that the object is slowing down. All right, and then here, our pink line, this is a 2-in-1 combo. So for example, this object would have been moving 8 meters per second, 6 meters per second, 4, 2, 0 meters per second. At this exact point where it crosses the x-axis, the object is not moving. So for 1 second, it pauses. Then it continues moving at the same speed, same change in speed. So maybe it's 2 meters per second right, 4 meters per second right, 6 meters per second right, 8 meters per second. So as you can see, at first the object was slowing down, then it stopped, and then it finally starts increasing in speed. So let's break down each part. So if a graph looks like this, and we have a velocity versus time graph, and we have this positive slope, so notice that it's a positive velocity. It's in this positive part of our velocity graph, and it's a positive acceleration because we have a positive slope. That means that the object is speeding up. So if you see a graph that looks like this, the object is speeding up. It's going from 0 to 4, 6, 8, 10 meters per second. And there is a pattern to it speeding up. It's a straight line. So there's some sort of constant increase in the velocity. 2, 4, 6, 8, 10. Some sort of pattern. All right, on the other hand, where we have this graph of motion, we start in the negative velocity. So we're starting in the negative velocity, but we still have that positive acceleration because it's a positive slope here. So the object is slowing down. So again, it could be 10 meters per second, 8, 6, 4, 2. So we are slowing down, but we're trying to move towards the positive position. So that's why it's a positive acceleration. We're moving towards that positive direction. We're moving towards the right. We may still be in the left of the origin because we're down here in the graph portion, but we're trying to move to the right of the origin. So positive acceleration. All right, on the other hand, we have negative acceleration. So you might already be thinking, yeah, negative acceleration, negative slope. That is exactly right. So that negative slope on the graph is just telling you that the object is moving in the negative direction. So it's moving towards the left or south. So for this green line, we have a change in the velocity of the object. So maybe the object's moving at 10 meters per second, 8 meters per second, 6 meters per second, 4 meters per second, 2, and then eventually if it hit this line, it would be 0. So the velocity is positive. It's in the positive portion of this graph, but it's a negative acceleration. So you have a positive velocity, but a negative acceleration. That means that the object is slowing down. It starts off moving at 10 meters per second, but it is slowing down. 10, 8, 6, 4, 2, it is slowing down. Now let's take this negative slope and move it down here. So this blue line. Now our motion is in the negative portion of our velocity. So negative velocity, meaning we're moving towards the negative position. So in this case, we're starting at the origin and we're moving to the left. We're moving to the left of the origin. So we start at 0, maybe we're going 2 meters per second, 4 meters per second, 6, 8, 10 meters per second. So although it's a negative acceleration and a negative velocity, the object is still speeding up. So our signs are the same, the object is speeding up. All right, and then in this red line, at first, the object is going 10 meters per second, 8 meters per second, 6, 4, 2. Here at this point where it crosses the axis, it pauses for just a second. Then it continues moving in this negative direction, so to the left. The whole time the object is moving to the left or south. But after it crosses the x-axis, now the object is speeding up. So it's going from 0 meters per second to 2, 4, 6, 8, 10, 12, 14 meters per second. So the object is speeding up and it's going in the leftward direction. So let's break down each part. So again, we have this green line and it's in the positive velocity. So it starts off moving with a positive velocity. It's on the positive part towards our origin, so maybe to the right or north. But it has a negative acceleration, meaning that it's moving towards the negative direction. So it's moving towards the left. So our object is at first moving 10 meters per second, 8, 6, 4, 2. Our object is indeed slowing down. And then on the other hand, we are in the negative velocity portion of our graph, and we still have this negative acceleration noted by the negative slope on our graph. So our object is speeding up. It's just speeding up in the negative direction. So it's moving to the left or south. At first, our object starts at 0. Then it goes to 2, 4, 6, 8, 10, 12, 14. So it is speeding up. It's just speeding up going towards the left. All right. So in summary, if we're talking about constant velocity, we're going to have this horizontal line. A line with no slope means a constant velocity. So this orange line means that the object is stationary. So here, the object is stationary. It's at 0. But this blue line, it means that it has some sort of constant velocity, and it's a positive constant velocity. It could be also down here. That would be a negative constant velocity. So these horizontal lines just tell you it's a constant velocity. So up here, it would be 1, 2, 3, 4 meters per second to the right. Here it would be 1, 2, 3, 4, 5 meters per second to the left. All right, but let's say that we have a positive slope. So a line that looks like this purple line. That positive slope indicates a positive acceleration. So it doesn't always mean that it's speeding up. In this case, yes, it's speeding up because the object starts at 0 and it's increasing to a velocity of 2 meters per second, 4 meters per second, 6, 8 meters per second. Yeah, that's speeding up. But if you have that same positive slope in the negative portion of your graph, that means something completely different. So the object's still moving towards this positive direction. Both objects of these purple lines are moving towards the right. However, the one down here starts at maybe 12 meters per second. Then it goes to 10 meters per second, 8 meters per second, 6, 4, 2, and eventually 0. So the object is slowing down. So just because something has positive acceleration does not mean that it's always going to be speeding up. Let's look at a negative slope. So a negative slope would give us a negative acceleration because the object is moving in the negative direction to the left. And it doesn't always mean that it's slowing down. In this case, yes, sure, it is slowing down. You're moving from 10 meters per second to 8 meters per second, 6, 4, 2. Yeah, we're slowing down, definitely. You can see that on the graph. However, if this green line is down here, that means something completely different. You start at 0, but then you're increasing in speed. It's just in the negative portion of the graph. So you're going from 0, 2, 4, 6, 8, 10, you are speeding up. You're just moving to the left or in the negative direction. All right, so that concludes our acceleration graphs for our acceleration motion for velocity versus time graphs. If you have any questions, please leave a comment. Thanks for watching.